Hi everybody, Matt Morgan here. In this lesson we're going to talk about balancing redox equations, specifically the ion-electron method in acidic solution. This is from Wiley section 14-3. We'll go over the steps for the ion-electron method and work an example in acidic conditions. You've done the bridge method for balancing redox equations, and that works well, and it's fairly simple, but it only works when our solutions contain monatomic ions. Well, some redox reactions occur with more complex molecules, and the bridge method won't quite work with that. The change in oxidation number is not so obvious. So when we do the ion-electron method, we're not going to draw a bridge between reactants and products. We're actually going to separate the reaction into two half reactions. The steps that we're going to go through come from Wiley section 14-3. We're going to go over all the steps and then we'll work an example. So the first step that we want to do is assign oxidation numbers to all the atoms that are reactants and products. That comes from Wiley section 14-1. We want to determine which reactant is oxidized and which is reduced. What is gaining electrons? What is losing electrons? We need to know where the electrons are going. Then we're going to split the reaction into two half reactions, and we're going to balance each half reaction separately. First, we'll balance all the atoms except hydrogen and oxygen. We're going to place coefficients just like when we balanced reactions back in General Chemistry 1. Then we're going to balance the oxygen atoms by placing water. This seems a little counterintuitive, but all our reactions are occurring in aqueous solution, which means water is our solvent. We've got water molecules all over the place. If we want to balance a reaction by placing water, we can do that. So after we place the water molecules, we want to balance the hydrogen atoms using H+. We can do that because the solution is acidic. We can have excess protons in an acidic solution. Then we're going to place electrons to balance the charges on both sides of the arrow. Remember, redox reactions are all about electrons, and eventually we want those electrons to cancel. We're going to check the half reaction for atom balance and charge balance. After each half reaction is balanced, we're going to multiply one or both, if necessary, to equalize the number of electrons. Each half reaction should have the same number of electrons. This is the same thing we did in the bridge method. Then we'll combine our half reactions and the electrons should cancel. There may be other species like H+ and water that may cancel. We'll watch for that. But our purpose is to cancel the electrons. And after the electrons cancel, the atoms and charges should be balanced. We might have some leftover H+, we might have some leftover water on one side or the other, but that's okay because our reaction occurs in aqueous acidic solution. Now that was a lot of steps. You've probably forgotten what we've talked about. Remember, reference Wiley section 14-3. We're going to go over the sections again, working an example. Here's our reaction. Solid zinc plus nitrate ion goes to zinc 2+ ion and nitrogen dioxide gas. Notice this reaction does not include spectator ions, and that's fine. We don't even want to mess with spectators. This process is going to be complex enough. So the first step, we're going to assign oxidation numbers for all atoms that are reactants and products. Once again, this is from Wiley 14-1. We've also got a video that will review how to do that if you've forgotten. Okay, the zinc is 0. It's a neutral atom. Is zinc 2+, has a 2 plus oxidation number. The oxygen has a -2 on both sides in the nitrate and the nitrogen dioxide. The other rule for assigning oxidation numbers, we know that the sum of the oxidation numbers equals the charge. So nitrogen on our reactant side has got to be +5. Because 3 of those -2's come together to be a -6, the overall charge is -1. That means nitrogen is +5. The nitrogen on the product side has a +4 to make the neutral nitrogen dioxide with our 2 oxygens. So, looking at this, our half reactions are zinc solid goes to zinc 2 plus, and nitrate ion goes to nitrogen dioxide. Let's balance these individually. Okay, with the zinc solid going to zinc 2 plus, we've got the same number of zinc atoms on both sides. They're balanced. There's no oxygen, there's no hydrogen, so all we have to do is place electrons to balance the charges. We have a +2 charge on the right hand side, electrons are negative, so we place 2 electrons on the right hand side. There's 1 zinc, neutral on the left, neutral on the right. Mass and charge is balanced. This one was pretty easy. Let's do the other half reaction. Not so simple. Nitrate ion going to NO2 gas. The nitrogens are balanced, but look, the oxygens are not. 3 oxygens on the left, 2 on the right. So we must place 1 water molecule on the right hand side. And that's what we get. Notice now that the hydrogens are not balanced. The next step is to balance hydrogens by adding H+. 2 hydrogens on the right, we will need 2 H pluses on the left. And there we have. The hydrogens and oxygens are both balanced. Final step, we need to place electrons to balance the charge. The right hand side is neutral. The left hand side has a +2 and a -1, so we must place 1 electron on the left side. That balances charges on both sides. Okay, we check mass. We're neutral on the left for charges, neutral on the right. We have 2 hydrogens on the left, 2 on the right, 1 nitrogen on the left and right, and we have 3 oxygens on the left and on the right. Let's look at both of our balanced half reactions. Next step. Okay, one thing to check is that we have electrons on opposite sides of the arrow, because eventually the electrons are going to cancel. If you balance redox reactions using this method and you end up with electrons on the same side of the arrow for both half reactions, back up. You'll need to do something again because the electrons must cancel. Now, are they going to cancel here? They're not, because there's 1 electron on the reactant side of the first half reaction, 2 electrons on the product side of the second. What we have to do is take this top half reaction and multiply everything by 2. This is what we get when we do that. 2 electrons, 4H+, 2 nitrates, 2 nitrogen dioxides, and 2 waters. The zinc we leave alone. Now we combine, and the electrons will cancel, which we remember is the purpose of balancing half reactions. We combine what is left. No H pluses cancel, no waters cancel. Watch for it, sometimes they might. So we get zinc, 4H+, 2 nitrates, go to 2 NO2s, 2 waters, and 1 zinc. We've got the same number of atoms on both sides. We've got the same charge on both sides. Notice we have 4H+ and 2 nitrates, giving us a net +2 on the left and a net +2 charge on the right. Now notice the charges do not have to be 0, but they do have to be the same on both sides of the arrow. So in this lesson we covered balancing redox reactions in acidic solution. We went through those steps. We worked an example, and as always, contact one of your course mentors if you have any questions about this material. The main job of your course mentors is to enable your success in these courses. You can email us at the group inbox at chemistry@wgu.edu, or you will find contact information for your individual course mentor in your course of study.